Hello, I'm Thad Plumley, the Director of Publications for the National Groundwater Association. I'm here today with Reed Maxwell, Ph.D., a professor at Princeton University and the 2020 Darcy Lecturer. Reed had a unique experience this year in that he gave all but one of his presentations virtually. Reed, what do you hope was the number one takeaway from those who were able to watch your presentations?
So hopefully a different takeaway from each of the three presentations, but
Yeah.
I tried to be really optimistic, and I'm an insufferable optimist. I think I always try to see the bright side of things, and I always try to see the positive side of things. And as a modeler, that's really challenging, or for three kind of modeling based talks. I guess the beetle talk is really more the most observational, but I try to play up how far we've come, and how many neat things we've done in understanding groundwater and understanding how we can use models, supercomputing to better understand groundwater. And I think it's as much as we can focus, and particularly in modelers, we always focus on the discrepancy, how every imperfection or every place where the model doesn't agree with the observation. But I think it's nice to try to take a step back and say, look at how far we've come, and look at how much we can do. And it's sure we've got a lot more to do. No model's perfect, and we're trying to improve that process, particularly with groundwater, where we have the challenges of not understanding what's underground completely, and not understanding where water is. But it's really important to be able to take a step back and say, wow, look at how much we've done, and look at how far we've come as a community. And I think that's one of the important messages. And I think it's also, one of the roles of the Darcy Lecturer is to focus on the positive.
Was there a question that you got over and over, regardless of when the presentation was played or given?
Definitely, you get a lot of the same questions, which is great because it means the community's somewhat on the same page, but it's also the downside because you think, wow, I should have, made that clear in my presentation, or that's an issue. One of the common themes was uncertainty, and how we address uncertainty in large models, which is, of course, super important. And, frankly, with the large scale modeling, we're not there yet. We'd like to be, but we're not there yet. Other questions really revolve around people, and how people interact with water, and how, moving forward, we might include more of how people interact water and use water in models. And I think that's another, not necessarily an issue in where we're at, but just something forward looking that we want to think about. And I think that's on the mind of the community, and very important, obviously.
Okay. Finally, I know you are part of a research project at Princeton that is modeling the nation's natural groundwater systems to improve water management. Can you tell us how that project's coming along?
Sure. So there are two synergistic projects that are going on right now that are both really exciting. I'm the PI, fortunate enough to be the PI of a project called HydroFrame, which is a framework that brings together computer scientists, hydrologists around large-scale hydrologic modeling. So it's not just the models themselves, it's the data, it's making the results available, and then it's really connecting the community to models and accelerating the modeling process. And at Princeton, we've built a large 3 petabyte data center and a small cloud computing system that we're using to really build this framework. And the second exciting project is called HydroFrame ML, for HydroFrame Machine Learning. And I'm the co-PI of that project. Laura Condon at University of Arizona is the PI. And that's a convergence accelerator. So that's one of these really fast-paced NSF programs that brings together, again, computer scientists, hydrologists, and then machine learning, data science and machine learning experts. And that's very user-focused. So we have two groups that we are shared partners or stakeholders that we're working with: the Bureau of Reclamation, who manages most of the West's water, and then the NOAA Geophysical Fluid Dynamics Lab, or GFDL lab, which manages, designs, builds, and contributes one of the global climate models for the IPCC ensemble. So it's thinking about how groundwater fits into those contexts in two very different ways. One is water in the West, more arid systems, and how water is managed by the Bureau of Rec, and building machine learning emulator models of groundwater models to feed into their management process. And then the other, on the GFDL side, is how we can use machine learning to build groundwater models that would fit into climate models so that we can include groundwater globally. So really exciting stuff. We're about halfway through HydroFrame and HydroFrame as a project, and then HydroFrame ML, we're only 2 months in, and it's a 9-month sprint for phase 1. So it's really busy, but it's really exciting.